Hello and welcome. In this video, I will be teaching you addition and subtraction of measurements with uncertainties. Students often don't understand why the uncertainties are added even when the measurements are subtracted. There is a detailed explanation to that in this video, and at the end of the video, there is also a problem where all this is applied. Let's first discuss how to add measurements when their true values and their uncertainties or absolute errors are known to us. As an example, let's assume a person is walking along a path, as you can see on the screen, passing by these trees. And the person estimates the distance between the first and second trees to be around 200 meters to 220 meters. And he estimates the distance between the second and the third trees to be around 300 meters to 310 meters. Now suppose we want to calculate the total distance between the first and the third trees. We do not know what is the exact distance between the first and second tree, nor do we know the exact distance between the second and the third tree. So we cannot tell the total distance from the first to the third tree for sure, but we can estimate, we can find out a range of values in which it could lie. Let us note the distance between the first two trees as A. Now we know it ranges from 200 to 220 meters. So we can write it as their mid value, which is 210 plus or minus 10 meters. Meaning that the distance between the first two trees could be anywhere from 210 minus 10, which is 200, to 210 plus 10, which is 220 meters. Similarly, we can note the distance between the second and the third trees as B. It ranges from 300 to 310 meters. Like it could be anything from 300 to 310 meters. So we can write it as their mid value, which is 305 plus or minus 5 meters. So we know the range of possible values of the first distance and a range of possible values of the second distance. Now we need to sum these two. We need to add these two and report the range of possible values of the sum. So basically what we need to do is we need to report the minimum possible value of the sum and the maximum possible value of the sum. Let's see how to do that. Now, if you want to calculate the minimum total distance between the first and the last tree, it makes sense to consider the least possible distance between first and second trees, and also the least possible distance between the second and third trees, which would make the total distance between the first and the third the least possible value. So for that, we consider 200 as the distance between the first two trees and 300 as the distance between the next two trees, which makes the minimum possible distance between the first and third tree to be 500 meters. And if you want to calculate the maximum possible distance between the first and the third tree, go ahead and try it on your own. Once you're done with that, you can continue with this video. To get the maximum possible distance between the first and the third tree, we would have to add the maximum possible distance between the first two trees and the maximum possible distance between the second and third tree, which will be 220 plus 310, that is 530 meters. So the range of possible values of the total distance is 500 meters to 530 meters. Now let us see how to express this as a true value along with some uncertainty. The range of possible values of the total distance is 500 meters to 530 meters. We can write this as their mid value 515 plus or minus 15 meters. Now there is also another way of writing this. 515 can be written as 210 plus 305 plus or minus, the 15 can be taken as 10 plus 5, all in meters. Now if you observe what we have just written here, 210 is the true value of the measurement A, and 305 is the true value of measurement B. So the true value of their sum A plus B is true value of A plus true value of B. And then look at the uncertainty. 10 plus 5, 15 is the uncertainty in the sum, which happens to be the sum of their individual uncertainties. So we can conclude that when measurements are added, their true values get added and their uncertainties also get added. So if you have a measurement A given like this and a measurement B given like this, then their sum must be expressed as A plus B plus or minus uncertainty in A plus the uncertainty in B. So you can remember it like this. When measurements are added, their uncertainties also get added. Let us next discuss how to subtract measurements when their true values and their uncertainties are known to us. So when the true value and the absolute error of two measurements is known, how do we report their difference? Let's say you purchased a lottery ticket, and in case you win the lottery, you get anywhere between rupees 10 lakh to rupees 12 lakh. So it depends. It's not known what is the exact price the winner is going to get. It depends on whether your ticket is chosen first, second, third, or so on. So you may win anywhere from 10 lakh to 12 lakh in case your ticket is chosen. Let's assume something like this. So this is like the gain. So let's represent it with G. So gain is anywhere between 10 lakhs to 12 lakhs. So we can write it as 11 lakhs plus or minus 1 lakh. In rupees. That's a pretty good amount to win, but there is a tax that you will have to pay in case you win the lottery. And the tax could range anywhere from rupees 2 lakh to rupees 4 lakh. So basically the tax is not fixed yet. The amount will be fixed on the day of the lottery. So let's call this as the loss, represented by L, and it would be somewhere between rupees 2 lakhs to 4 lakhs. So we can write it as 3 lakh plus or minus 1 lakh. So if you win the lottery, you will earn anywhere between 10 lakh to 12 lakh, and you will have to pay a tax somewhere between 2 lakh to 4 lakh rupees. So the net amount that you would pocket, let's call it as N, can be calculated like this: G minus L, gain minus the loss. Now we don't know the gain for sure, we don't know the loss for sure. So we cannot calculate the net amount that we will pocket for sure, but we can express a range. What is the minimum amount that we are going to gain, and what is the maximum possible amount we are going to gain? So let's see how to do that. Let us first calculate the minimum net amount that we can pocket. Now go ahead and try to calculate it yourself as to what would be the least possible amount that you can win if your ticket is chosen. Once you're done with that, you can look at the explanation. To calculate the minimum net amount, we will assume that we win the smallest amount in the lottery and we have to pay the highest amount of tax. So you win the least possible amount and you pay the highest possible amount. So in that case, the net amount that remains with you is going to be the least. So to calculate the minimum value of N, you will have to take the minimum value of G, and from it you subtract the maximum value of L. So that would be 10 lakh minus 4 lakh. So 6 lakh rupees is the minimum amount that you can pocket in case you win the lottery. Let us next calculate the maximum amount that you can pocket. Go ahead and try it yourself. And once you're done with that, you look at the explanation. To calculate the maximum net amount, we need to assume that you win the highest amount from the lottery and you pay the least amount of tax. So N max, the maximum value of the net amount, can be calculated as G maximum, the maximum gain, minus the minimum loss. That would be 12 lakh minus 2 lakh. That is rupees 10 lakh. So the maximum amount that you can win if your ticket is chosen is rupees 10 lakh. Let us express this as one term. The minimum net amount, which is the minimum of gain minus the loss, is rupees 6 lakh. And the maximum net amount, which is the maximum value of gain minus loss, is rupees 10 lakh. Now, if we express N as a range, we could write it as the mid value of 6 lakh and 10 lakh, that is 8 lakh, plus or minus 2 lakh. In rupees. Now, if you observe, 8 lakh is 11 lakh, which is the true value of G, minus 3 lakh, which is the true value of L, plus or minus 2 lakh is 1 lakh, which is the uncertainty in G, plus 1 lakh, which is the uncertainty in L. So what we see here is when two terms are subtracted, their uncertainties are still getting added. Their true values are getting subtracted, as you can see, 11 lakh minus 3 lakh, but their uncertainties are still getting added. So we can write this as G minus L, which is the difference between their true values, plus or minus uncertainty in G plus uncertainty in L. So even if measurements are subtracted, their uncertainties would get added. In general, if there are two measurements A and B, A given as A plus or minus delta A and B given as B plus or minus delta B, A minus B should be expressed as true value of A minus the true value of B plus or minus the uncertainty in A plus the uncertainty in B. Even if measurements are subtracted, their uncertainties still get added, because what we want to report is the maximum possible deviation of that difference A minus B. And in that process, as you have just seen, it so happens that the uncertainties still get added. Now you can remember it this way: uncertainties are never subtracted. It doesn't matter whether you are adding the measurements, subtracting the measurements, multiplying them, dividing them, or whatever you do, uncertainties should never be subtracted. Let us also discuss how to express multiples of a measurement when its true value and uncertainty or absolute error are known. This is quite simple. Now, n times of A is just A added to itself n times. So it's just like adding a measurement with itself n times. Now, when measurements are added, we know their true values get added and their uncertainties also get added. So NA could simply be written as A plus A plus, A added to itself n times plus or minus its uncertainty added to itself n times, which can be written as NA, which would be the true value, plus or minus n times delta A, which would be the absolute error. Now there is a chance that n is a negative value. So to make it true in general, we express it this way: NA plus or minus modulus of n delta A. This is because uncertainties will always get added. Even if the measurement is multiplied with a negative sign, the uncertainty is to be kept as a positive value, as I have mentioned in my last video. So to make it a positive value always, we use the modulus sign. So this is how we express multiples of a measurement. Now one interesting thing you can note here is that n could be any real number. It could be a positive integer, it could be a negative integer, it could be a decimal value, it could be a fraction, a square root, a cube root, whatever it is. The result is true in general. It is mathematically proven and you can use it. So if a measurement is multiplied by a value n, its true value gets multiplied by n itself, and its uncertainty gets multiplied by the modulus of n. Let us apply whatever we have learned in one problem. Let's say the length of a rectangle is given as 20 plus or minus 0.5 centimeters, and its width is given to be 11 plus or minus 0.2 centimeters. And suppose we have to calculate its perimeter. We know that the perimeter of a rectangle is 2 times the sum of its length and width. So what we will first do is we'll find out the sum L plus W first, and then we'll multiply it with 2 so that we can report the perimeter along with its uncertainty. The sum of its length and width, L plus W, can be written as 20 plus 11, the sum of their true values, plus or minus 0.5 plus 0.2, which is the sum of their uncertainties or absolute errors. So this can be written as 31 plus or minus 0.7 centimeters. And then we can express the perimeter, which is 2 times the sum of the length and width, as 62. The true value gets multiplied with 2, and the uncertainty also gets multiplied with 2. 0.7 taken twice is 1.4 centimeters. So this is the proper way to express the perimeter of the rectangle. Now let's just suppose you have to calculate L minus W for some reason. It can be calculated as the true value of L minus the true value of W plus or minus. Now just recollect that even if measurements are subtracted, their uncertainties are still to be added. So 0.5 plus 0.2, which becomes 9 plus or minus 0.7 centimeters. This is the correct way to express L minus W. So hope you have found this video useful. In the next video, we will be discussing how to multiply and divide measurements along with their uncertainties. Hit like and subscribe to my channel if you want more content like this. Thank you.